Howdy everybody, and welcome back to the Mega Man tutorial. So last time we added another enemy, the rabbit, that would jump around and follow Mega Man around the screen and shoot carrots at him. But we also mentioned that we want to do some more transition work so that we can actually leave this room and go to another room. The reason being because we have other enemies we want to add into the game and other effects like checkpoints that the Mega Man needs to be able to reach, plus, a boss. So let's get cracking. Come back in over to our rooms here. Not rooms, objects. Our game objects, and pop open our camera. Give me a second here. Whoops, wrong one. Not shaders, not fonts. Need game objects, object camera, and targeted state. So we're gonna need to do a little bit of work on this. So you may remember. Well, I guess we won't really need to do any work on this, but I come back here to tell you about, you may remember our object room boundaries that we've set up. And we come over here, you remember we have the layer here with room boundaries inside of it. And so far we've only made one additional room right there. So, and this room is this one right there. The main reason why we have these is so that we can delineate where we want a transition to occur. And when that happens, we detect where our room is and then clamp our camera to the top of the room and allow our camera to slide over the x-axis inside of the room. But we want to be able to create a transition, so we need to pop open the player object here. Come over to our steps. And we're going to start doing a little bit of work on this transition check region here. So currently we have it set up to create a list of all the room boxes you might be hitting at any one given time. And I have no idea if this really works at all, because there isn't really any instances in Mega Man where you have 1, 2, 3, 4 rooms all in the same place where you could possibly hit a corner and transition into all the rooms at the same time. So I'm just guessing that this might work. As far as the actual game goes, it's set up pretty much so that you can only ever do one transition at a time, going down into this room or going up into this room, down or up, left or right. You can only really do one type of transition at a time. You can't really go into multiple transitions at one time. Anyways, so we currently have it set up if our current room is equal to no one, then current room is equal to list 0. So we're basically saying that if the current room variable, which starts out as no one, is still no one, then set our current room to be whatever the room is that Mega Man has teleported into. That sounds logical, right? And because Mega Man starts at the left side of the screen, typically, so you'll end up with the camera on the top left of the screen, and when we put in the checkpoint, he'll be starting right there. Camera will start up right there. Kind of the same thing for over here. You get a checkpoint right here in this room, and so you'd have the camera starting right there, so on and so forth. So this works as far as it goes in my testing. So, but what if there is already a room? If we've already set it, So when we actually do a transition from this room to this room, we'll end up having like half of Mega Man in this room at a time and half of him down in this room, because he doesn't move fast enough that his entire body will fall out of the room in one frame. So this works as far as that goes, but it wouldn't work if you were able to move faster than the character is wide or tall. So that would be something to keep in mind. So what we're going to do here is I'm just going to copy and paste all this code here, as I usually do. So we have a setup here. So var I equals 0 while I is less than rooms I plus plus. So we're going to loop through our rooms. So we've created this list. We've detected that we're in 2 rooms at the same time. So we're going to loop through the list. And if the value in rooms if the value in rooms is not the current room, so it's detecting the first instance in this room list that is not the room you're currently in. So that way, if you had it doesn't matter what order the room list detects what so it could detect that you're in this room first and add this in as the first as position 0. Then it could detect that you're in this room, so it put this in at position 1, or it could put in this at position 0 and this at position 1, and it won't matter which one you do. That way, order doesn't matter. So if our current I does not equal our current room, then new room is equal to list at our current position. So we want to set the new room that we're moving into as whatever the value in that list was at this point. Then we have this setup here, which is basically the same code each time. So if bbox right is greater than or equal to current underscore room dot bbox right. So if the right side of Mega Man is outside of the room here, then we're probably moving to the right. So our transition direction will be to the right, dirt4.right. And then we create on the instances layer object player transition. So we'll need to create object player transition, and I should probably do some zoom in, alright, shouldn't I? Let's make sure you can actually see that. Can ya? Good. There we go. Just under player object, create object underscore player underscore transition. And we'll pop it open. It does not get a sprite because it actually inherits its sprite from the player. So there's a lot of different things that we're going to do with this. We set up a bunch of variables here. So var underscore player is equal to object player.id. Won't work if there's multiple players. Weapon underscore is equal to object player.weapon. And the reason why we're going to be grabbing this information here is so that we can, well, first off, we get object player.id because I really didn't want to have to go and write object player dot. Instead, I just did underscore player, and it's really kind of redundant how I did that completely entirely. But, you know, I did it. So we have animation speed. So we set ourselves up to have whatever the player's animation speed is. New room is equal to that new room variable that we currently set. Current room is equal to new room. Yeah, you got to do that or else you end up, if you don't change the current room to the new room, then you end up transitioning back and forth infinitely, and that's no fun. Transition and direction, again, grab cribbed from the player. Sprite index is cribbed from the player. Image index cribbed from the player. Image speed is equal to 0. Image x scale is equal to player's x scale. X is equal to player.x. Y is equal to player.y. And our y start is equal to our y. So we just change our y start position to make sure that it is wherever we've set ourselves to. That way, if the origin of the player object is completely different from wherever we spawned at this object in the first place, it won't matter, hopefully. And animation timer is second times 0.5. Transition finished equal to false. Object camera.state is cam mode.free. We need to make sure that the camera is free, so it's no longer fixed to the room. Otherwise, when we're transitioning, the camera will just stay right there until the transition's over, at which point then it'll jump to there. So we don't want that to happen. We want the camera to move along with the transition. And boss door is equal to false. We use that for when we're doing a boss door transition. And last but not least, we need to deactivate a bunch of objects. So we want to deactivate the parent enemy, the parent projectile, the parent enemy projectile, the player object, and spawners. The reason why we're deactivating all these things is so that they don't end up spawning new enemies or something while we're doing the transition. And we don't want the player to be able to move around or anything during the transition, so we just deactivate the player's object. And projectiles we deactivate, and that pretty much it also eliminates the projectiles because they will disappear once they are no longer inside of our view. And parent pickup, we haven't made that yet. You can just go down into the parents section and create a parent pickup object. Don't have to actually do anything with it yet. Just make the object so that it won't give us an error. So then we just need to go over to the draw event and remember to draw ourselves, but we also want to, there will be some work here with palette swapping in a bit. I'll get in there as well, so we'll just ignore it for the time being though. Add a step event, and that's where the rest of the magic of this transition will happen. So to get us started off, we want to have a wait. If our animation timer is greater than 1, so as long as we haven't actually reached 0 on the animation timer, then we count down the animation timer. Because there is like a little 1 second, half-second delay when you hit the border of the room before you actually start transitioning. I don't know if that's because the NES was slow or because that was actually the intended effect. Because, I mean, the transition could start instantly as soon as you hit the border, but they chose to wait half a second. Then we need to do a lot of copy-paste code again. This will be based on our transition direction. And when I say copy-paste, I mean that we're going to copy-paste this 4 times so that we can do it for every single direction. So we could also use a switch, that would work just fine too, but I chose to just use a bunch of if-else ifs for some reason. It's the same thing. Move me in the camera. So this transition object, as we've seen so far in the create event, takes the place of the player object for the duration of the transition. So then sprite index does not equal Mega Man climb. Mega Man, when he's climbing, doesn't animate for some reason versus other sprites where he does animate during the transition. And you could actually see this in I believe Legend of Zelda as well, where sometimes Link will animate his walking while doing the transition between the rooms, and in some other instances he won't. I don't know for sure, but anyways. So we set our image speed equal to the animation speed so that our character animates during the transition, because that's what they did. Our object camera.x is equal to approach object camera.x to new room.x at 4 pixels per frame. So what are we doing here? So we have our camera, so we're moving to the right, and we want to move our camera. So if this was the room here, we want to move our camera from there to there. So we move it by using our approach script to approach object camera.x towards the new room's new x position, which is dictated by where the room starts, right over here in the top left corner right there. And we're going to do that at 4 pixels per frame. And var underscore size is equal to bbox right minus bbox left. So this would be the size of the player's current sprite plus boss door times 2. So the reason for the boss door is so that we can have a little bit of extra space here, because we want to move the player an extra. Let's see if I can show it to you. So the boss door will be in this space right here. Normally you would transition from here to there, but since the boss door is right there, you would need to transition from here to there. So we add in an extra, if it's a boss door, then you add in the extra character width into the transition. Then x is equal to, so that we moved the camera, we've gotten the x value, so we've gotten the size value that we need to know for how far we're going to be moving. Then we do x equals approach our x from our x start plus size to size by the rate of x divided by 64, because we want to move in a 64 frame, over 64 frames, we want to move our full 256 pixels. So this little formula here just divides our movement into 64 frames. Then when we finish the transition, our object camera.x is equal to new room.x. This is just a, theoretically it should already be there because of this, but just in case. Oh wait, no, I had that completely wrong. I'm saying that once the camera's x is equal to new room.x, we've finished our transition. And once our x is equal to x start plus size, so once we've reached the position that we want our player object to have reached, then the transition is finished, and our animation timer is equal to sec times 0.5, because there's another 0.5 second delay before the transition is completed. So once transition is finished, though, we'll put this up here. So the next frame after the transition is finished, we reactivate all the objects that we previously had deactivated and place the player at our new location. And then we set the camera's state back to targeted, and the next frame, in the next frame, the camera's target should update back to the new room by using the player's targeting code. And then we destroy the transition object since it's no longer needed. So I think this works out pretty well as far as it goes. I think I could probably make it simpler in the future, but This is a first run at this system. We'll see how it evolves in the future. Like it has evolved fairly well for other stuff like the input object. So now we got to do pretty much the exact same thing, except we're going to slightly edit all the variables for the other directions. So we have our direction up. If sprite index did not equal Mega Man climb again. Now we're working with the Y variable. Transition by 4 again. And our size is now B-box top bottom to B-box top rather than B-box right to B-box left. And this little bit is still the same right there. Y is approach Y to Y start minus size. Size divided by 60. And you may be wondering why we're divided by 60 here instead of by 64. And the reason is because I don't remember off the top of my head here. It's because the upwards movement has less travel than the downwards movement, than the left-right movements. So you don't have to. So it's only 60 frames instead of 64 frames. And that's because in the NES games they were doing everything. They cut off the bottom 8 pixels of the bottom and the top 8 pixels of the frame for CRT monitors, as I mentioned back in the views in the camera setup section. So we do that. Y start minus size divided by 60. Finish the transition again. So once our camera has reached the new room's Y position and our Y is at our Y start minus size. So we were going from, say, here to here. So you don't have to go that far. Then transition is finished. Animation timer equals sec times 0.5. And again, for going left, it's almost the same, except we make a slight difference here in that instead of being plus size, we now go to minus size. And instead of x start plus size, we x start minus size there as well. And same differences in our... So we had right, up, left, and of else, which is just down. So our camera dot down be to Y plus size, and we want Y start plus size. All right, I think that's everything in there. So let's give it a check. See if it works. Alright. Oh yeah, he can't hurt us yet. So we'll ignore him for the moment. See, there we go. Perfect transition, right? But there won't be any here because we haven't put any new rooms in yet. So let's do that real quick. Since we are doing our rooms here, we'll just come over here and turn back on the room boundary so you can see it again. Go over to room object, grab a room boundary object. Drag them in. Each one of them is about the right shape for the most part. It's very simple because you barely have to do anything with it. This one right here, you need to stretch all the way across like the first room. More and more. there. Stretch that over to there. Throw in our boundaries, and last but not least, there we go. Now they all have boundaries. So yeah, I'm going to hopefully improve this system more in the future. We'll see how it goes. Let's check the tutorial time. We are currently at 24 minutes, so that means we are completed. We have demonstrated that all of our code works, that we can transition between rooms. That is great. So let's read off some Patreon sponsors then. I'd like to thank our current Patreons: Fragile Hearts, Crew Patreon, Damien, whoop, missed him, Kenneth Klein, John Dickey, and Vladimir Soldatov for your support of the NES GameMaker. This show wouldn't exist without the support of viewers like you. Trying to go for a PBS-like thing, but it doesn't really work very well. Anyways, so just remember, if you have any questions or comments, leave them in the comments section or get onto the Discord and hit me up, and hopefully I'll be able to answer them for you. If you have a really tricky problem, I might even feature it if you can show it, because I'm looking for something good for showing off some debugging for people so they can see how to do the debugging properly. Anyways, thank you very much, everybody, for watching, and good luck with your programming.